All right, this last example is kind of the big one for 7.5 day one. This will also spill over into tomorrow a little bit. Today we're going to focus on the graphing of inequalities part of this, and then tomorrow we're going to focus on actually solving the problem, which is going to be using something called linear programming, which you may have encountered before. But here's what we're doing. We're packing for a canoe trip, and it's our job to plan the kind of food that we're going to take along. We have special food bars and cartons of special drinks. So those are the only two items we're going to have. And they're telling us here that we need to provide for a minimum daily requirements of fat, carbs, and protein. Each food bar has 5 grams of fat, 40 grams of carbs, 8 grams of protein. Each drink carton has 6 fat, 25 carbs, and 15 grams of protein. And then important for us to know are the minimum daily requirements, because if you don't meet these requirements and you're on a month-long trip, then the assumption is that you would die. So 61 grams of fat, 350 grams of carbs, and 103 grams of protein. Maybe you wouldn't die, maybe you would just have a really miserable time, who knows. But the thing that we're not going to focus on quite as much today is the weight down here. That's going to get into the linear programming tomorrow. We're just going to focus on how we can represent these important minimum daily requirements as far as today goes, and we're going to put that into a system of inequalities. Now, what you'll see, there's a lot of information here, but one thing that we're going to need to do with any of these problems that at least are for this class is we're going to have to define the variables and determine a system of inequalities. Now, in this class, we never do more than 2 variables in a particular problem. We have x and y. So when we're defining the variables, what we have to do is think about, well, what's x and what's y? There isn't going to be a z because we just don't deal with z's in pre-calc. That is for multivariable calculus. We're just not going to be covering that. So if I look back at this one, I've got to think about what sort of things come in a pair. Now, when you look at these food bars and you see fat, carbs, and protein, that can't be it because there are 3 things in that case. So we're going to ignore that part. The part that comes in a pair in this case is the food bars and the drink cartons. So we're going to label, and this is, you could do it either way, but I'm going to just work off of the fact that x is going to be the number of food bars that we bring. So I'm going to define that variable right now, and then we're going to make y, the other thing is just the number of drinks that we bring along. So we have these variables defined. Now we're going to make a system of inequalities to take care of this. One thing that you can always do with this system, if you're wondering what do you start with, is let's look at these variables and think about what is the absolute minimum they could be. Now, the absolute minimum that I could bring along for food and drink on this trip is I could just forget to bring anything. I could bring 0. I can't bring negative, but I could conceivably bring 0 and just die very quickly. So what we can say here is that x needs to be greater than or equal to 0, and then also y is going to be greater than or equal to 0. Those are kind of your freebies in every problem. Those will be there each and every time. Now let's look at the requirements for fat, carbs, and protein. We said on this previous page that a food bar provides certain amounts there, 5 fat, 40 carbs, 8 grams of protein, and then there are some minimum daily requirements. And so what we've got to do is we've got to put these things together. Now let's look at the fat in particular. So the fat from each one, we've got 5 grams of fat here, we've got 6 grams of fat here, and then our minimum daily requirement is 61. So whatever we have, if that's the minimum, we could have more than that. That's kind of what we're looking at here. So if I've got 5 from the food bars and 6 from the drink cartons, I can express that as 5x plus 6y. Now I said that our minimum daily requirement for the fat was 61 grams, so whatever this is can be greater than or equal to 61, and that's going to take care of fat in this case. Now we're going on to carbs in a very similar way. Carbs, we have 40 carbs for the food bars, 25 carbs for the drink cartons, and the minimum daily requirement is 350. So we put it together much in the same way here, is 40x plus 25y needs to be greater than or equal to 350. Okay, so that takes care of carbs. Last one is the protein. Protein is going to be, it's down here looks like, so we've got protein, protein, and protein. So we've got 8, 15, and 103. All right, so that'll be our last piece here. 8x plus 15y needs to be greater than or equal to 103 grams. And so this inequality will allow us to get a graph that shows us what we absolutely have to have in order to stay alive on this trip. Now I have rewritten this one to clean it up just a little bit. We're going to be graphing this system of inequalities, and since there's a lot of stuff going on here, what I've chosen to do is to graph these by intercepts. So if I just look at my fat, carbs, and protein, the fat had these two intercepts. I'm trying to get really precise with those if I can, because I need to know where they cross over. Carbs and protein, I just have my intercepts that I'm going to graph, and I graph them. You'll see them right here. So with this now, I've got all these lines in here. It's a little hard to see, but what you might notice is that this one here, this bottom line is going to be the 12.875 as the crossing over point here, and this is the 6.86. So this one is protein right there. Probably easier to see when you're looking at the PDF notes because they are color coordinated. This one right here with the 14 and the 875, this one is going to be carbs. And then our last one is going to be fat. So all three of these lines are present, and they give us a boundary for what we're looking at here. Now each and every one of these, if you remember from our system of inequalities, each and every one of them was greater than or equal to. So we want to shade things that are up in this case. So that means that our shaded region is going to be everything up here, and that should make sense when you think about it, because if I wasn't concerned about weight and I brought 100 food bars, 100 drink cartons, I'd land somewhere up in here, and I would have plenty to meet my minimum daily requirements. It's just that I would be carrying way too much. So when we pick up this example tomorrow, we're going to talk about how can we minimize the weight, how can we make this an actual enjoyable trip yet still remain alive based on the nutrients that we're getting from these food bars and drink cartons.